The position vectors of two 1 kg particles A and B are given by RA equal to alpha 1 t square I cap plus alpha 2 t j cap plus alpha 3 t k cap meter, and RB, the position vector of B, is beta 1 t I cap, beta 2 t square j cap plus beta 3 t k cap respectively. Now alpha 1 is 1, alpha 2 is 3n, and alpha 3 is 2, and beta 1 is 2, beta 2 is minus 1, and beta 3 is 4p, where t in time n and p are constant. So the position vectors of two 1 kg particles are given RA and RB, and at 1 second mod VA equal to mod VB. So at 1 second the velocities of the two particles are same, and velocity VA and VB of the particles are orthogonal to each other. So at 1 second the velocity are equal and orthogonal, that is the angle between the two velocity VA and VB is 90 degree. At t equal to 1 second, the magnitude of angular momentum of particle A with respect to the position of particle B is root over L kg meter square per second. The value of L is. So at 1 second we have to find the angular momentum of A with respect to V. So now first calculate these constants, that is alpha 2 there is n and beta 3 there is p. So n and p we have to calculate from the given equation, that is at 1 second VA equal to VV. So first calculate VA. So we know that V is d dt of RA. So d dt of RA. So first derivative of the position vector. Now RA is, it is RA. So alpha 1 t square. So t square, the derivative of t square is 2t. So 2 alpha 1 t I cap plus alpha 2 t j cap, the derivative of t is 1. So alpha 2 j cap plus alpha 3 t k cap. Now t is, the derivative of t is 1, that is alpha 3 k cap. And if we put the value of alpha 1, alpha 2 and alpha 3, then VA becomes 2 alpha 1. Alpha 1 is 1, that is 2t I cap. Alpha 2 is 3n, that is 3n j cap plus alpha 3 k cap. So alpha 3 is 2 given, so 2 k cap. And similarly if we calculate VB, that is d dt of RB, so the RB is beta 1 t I cap. So beta 1 I cap, so the derivative of t with respect to t is 1. Beta 2 t square, that is twice beta 2 t j cap plus beta 3 k, that is beta 3 k cap, and put the value of beta 1, beta 2, beta 3, that is beta 1 is given minus 1, that is minus I cap, plus beta 2 is given as, sorry, beta 1 is given 2, that is plus 2 I cap, and beta 1 is given 2 and beta 2 is minus 1, that is this becomes minus 2 t j cap plus beta 3 k cap. So beta 3 is 4p, so 4p k cap. So this is VB. So we get the values of VA and VB. Now first it is said that velocities are orthogonal, that is VA dot VB at t is equal to 1 second. So put the value of t is equal to 1. So VA dot VB, that is 2t times 2I, that is 4t, and t is 1, that is 4. 3n minus 2t, so minus 6n t, t is 1, so 6n plus 2k plus 4p, 2k cap plus 4p cap, that is k dot k is 1, so 4 into 2, that is 8p. So this is equals to 0. So 6n is equal to 4 plus 8p, or 3n is equal to 2 plus 4p. So let's say this is the equation number 1. And again mod of VA is equal to mod of VB. So mod VA equal to mod VB. So now mod VA, so VA is 2t I cap. So and t is 1, that is root over of 2 square, that is 4, plus 3n square, that is 9n square, plus 4 is equal to mod of Vb, that is Vb is 2i, that is 4 minus 2t j cap, so plus 4 plus 4p k cap, that is 16p square. So this is the magnitude of the, so 4 plus 4 8, and 8 plus 9n square equal to 8 plus 16p square. So 8 cancels from both the side, that is 9n square is equal to 16p square. So 9n square is equal to 16p square. Now, so this becomes 3n equal to 4p, or 4p equal to, from here we can write 4p is equal to plus minus 3n. So 4p is equal to plus minus 3n. Say, let's say this is equation number 2. Now from 2 put the value on 1, that is 4p equal to, if we put 4p is equal to plus 3n in equation 1, then the equation is not valid, that is 3n cancels, that is 3n equal to 2 plus 4p. So if we take 4p is equal to plus 3n, then 3n cancels from both the sides, so it can be, it is not possible. So 4p is equal to minus 3n, so minus 6 to minus 3n from equation 1, or 6n equal to 2, or n equal to 1 by 3. So n equal to 1 by 3, and 4p is equal to minus 3n, so 4p is equal to minus 3n, or p is equal to minus 3n is n equal to 1 by 3. So this becomes p is equal to minus 1 by 4. So p is equal to minus 1 by 4 and n is equal to 1 by 3. So we get the value, that is 3n is equal to 1 and 4p is equal to minus 1. We get the two values, that is 3n and 4p here. So this is, let's say this is the equation 3. So we have calculated the constants n and p. Now we have to calculate the angular momentum of particle A. So the particle A, so we know that angular momentum j vector is equal to r cross p, that is r a b, that is the position vector of A with respect to B. We have to calculate the angular momentum A, so the position vector should be the of A, that is r a b cross m v a. So r a b cross m v a. Now m is 1 kg, as both the particles have same mass, is 1 kg. So now first calculate RAB. So calculate RAB, that is RA at 1 second. So t is equal to 1, at t is equal to 1 second, RAB is equal to RA minus RB. So RA minus RB. Now RA and RB is given. So RA and RB is given, from equation we can write RA is alpha 1 t square. So alpha 1 is 1, that is t, and t is 1, so at 1 second. So RA is I cap plus alpha 2 t j cap. Alpha 2 is 3n and 3n is again 1 from equation 3. 3n is 1, that is I cap plus j cap plus alpha 3 t k cap. So alpha 3 t, alpha 3 is 2, that is 2k cap, I plus j plus 2k. This is RA minus RB. Now RB is beta 1 t I cap, beta 1 t I cap. So beta 1 is given as 2, so 2 I cap, and t is 1. Beta 1 minus beta 2 is 1, that is minus j cap, plus beta 3 t k cap. So beta 3 is 4p, again 4p is minus 1, so minus 1, that is minus k cap. So RA minus RB, it becomes 1 minus 1, that is I cap minus 2 I cap, that is minus I cap. So minus I cap plus j minus of minus j, that is plus j, j plus j, that is 2j cap, 2k minus of minus k, that is plus 3k cap. So RAB is minus I cap plus 2j cap plus 3k cap, and Va at t is equal to 1 second, at t is equal to 1 second, Va is, we have already found Va, so Va is 2t I cap plus 3n j cap plus k cap. So 2t I caps, that is 2i, 3n is 1, so 2i plus j plus 2k, 2i plus j plus k, 2i plus j plus k. So Va is 2i plus j plus k, as 3n is equal to 1, so we put the value 3n, that, so 2i plus j plus k. So Va is like this. Now we have to find this, that is j is equal to Rab cross m. Va mass is 1 kg, so m is 1, so m is 1 kg, so find j is equal to Rab cross Va, because m is 1. Now Rab, that is, calculate this cross product, that is ijk. Now Rab is minus, this is the Rab equation 4, that is minus 1 minus I cap plus 2j cap plus 3k cap, this is R, and 4 minus 3 is 1i plus j is minus 1 into 2, that is minus 2 minus 6 plus k cap times minus 1 minus 4 is minus 5 k cap. So this becomes I cap minus 8j cap plus 5 k cap. So the magnitude of j vector is equal to root over of 1 square plus 8 into 8 is 64 plus 5 into 5 is 5 square is 25. So this becomes root over of 90. Now in the question it is said that the angular momentum is root over L. So angular momentum is root L, and we have to calculate the value of L. So equate this with root L, that is root j is equal to root 90 is equal to root L, that means L equal to 90. So the value of L is 90. So 90, L is 90. This is the answer. Thanks for watching. Please like this video, subscribe my channel and share this video. Thank you.